Cognitive computing, transforming the future of technology. By combining artificial intelligence, machine learning, and natural language processing, cognitive systems have the ability to understand, learn, and interact with humans in a more human-like manner. In this video, we will explore the limitations of traditional computing systems, the potential of cognitive computing, and its impact on various fields such as drone technology, synthetic biology, nanotechnology, and real-time system monitoring. The limitations of traditional computing systems. Traditional computing systems have served us well for decades, but they have their limitations. These systems are based on predefined rules and algorithms, which means they can only perform tasks they have been explicitly programmed to do. The potential of cognitive computing. Cognitive computing, on the other hand, has the potential to overcome these limitations. By leveraging machine learning algorithms and natural language processing, cognitive systems can analyze vast amounts of data, learn from it, and make informed decisions. Drone technology. One area where cognitive computing is making a significant impact is drone technology. Drones equipped with cognitive systems have the ability to analyze real-time data, such as images and videos, and make intelligent decisions based on that data. For example, a drone can be programmed to recognize objects or analyze patterns in a specific area. This has applications in fields such as agriculture, where drones can help monitor crop health, detect pests or diseases, and optimize irrigation. Nanotechnology. In the field of nanotechnology, cognitive computing is enabling breakthroughs in materials science and manufacturing. By analyzing data from experiments and simulations, cognitive systems can identify new materials with specific properties, optimize manufacturing processes, and even predict the behavior of nanostructures. This has applications in fields such as electronics, energy storage, and healthcare. Real-time system monitoring. Real-time system monitoring is another area where cognitive computing is making a significant impact. By analyzing data from sensors and other sources in real time, cognitive systems can detect anomalies, predict failures, and even recommend actions to prevent downtime. Data sovereignty. With the rise of cognitive computing, the issue of data sovereignty becomes increasingly important. Data sovereignty refers to the concept that data should be subject to the laws and regulations of the country in which it is collected. This is particularly relevant when dealing with sensitive data such as personal information or intellectual property. Organizations and individuals need to ensure that their data is stored and processed in compliance with local laws and regulations to maintain control and protect their privacy. Data security. In the era of cognitive computing, data security is of utmost importance. With cognitive systems processing and analyzing vast amounts of data, organizations and individuals need to ensure that their data is protected from unauthorized access, manipulation, or theft. Robust encryption, secure storage, and strict access controls are essential to maintain data security in cognitive computing environments. In conclusion, cognitive computing is transforming the future of technology across various fields. Its ability to analyze vast amounts of data, learn from it, and make informed decisions opens up new possibilities and accelerates innovation. However, it is crucial to address the limitations of traditional computing systems, ensure data sovereignty, provide user-friendly interfaces and mobile apps, and prioritize data security to fully harness the potential of cognitive computing.